So attached you find this project here. You can simply download it, extract it, run npm install inside of it, and then npm start, and you will see this page on localhost 3000. Now that's a very simple dummy app where you can enter any credentials of your choice. That's not a real authentication screen yet. For the moment, it's just a dummy screen. As long as you have a valid email address and a password that is at least 7 characters long, you can click the login button and you're on this dummy welcome screen. These links won't do anything, but the logout button will take you back. So it's a very simple dummy app. At the moment, there is no real authentication logic. We'll dive into that in a separate module. But it is a good enough example to practice the use effect hook and side effects therefore, and also the other core concepts of this module. So what's up with this use effect hook now? Well, what could be a good side effect here? Sure, we could send a HTTP request to a backend server, which validates our email and password, but at the moment we have no such server, so therefore I want to do something else. At the moment, when I log in with any dummy credentials, which are an email and at least 7 characters long for the password, if I click login, I am logged in this dummy mode. But if you reload this page here, you always lose this login status. And that is probably not something you want. Now, in reality, you would, of course, once you log in, send a request to the backend and get back some login data. For example, some token which identifies this user as authenticated. Again, more on that in the authentication module. But you want to make sure that this user is authenticated status is also still there once you reload the page. At the moment we lose this because in the app.js file where I manage this simple isLoggedIn state, it's just managed as some React state. And therefore it's just in the end managed in some JavaScript variable behind the scenes by React. Now, the nature of that is that when you reload your application, your entire React script restarts and all variables from the last execution are lost. That's how the web and scripts and the browser works. This is nothing React specific. Now, since we lose all the data when this restarts, it would be nice to store it somewhere where it persists the reload. And even better than that, we also want to make sure that whenever this app does start, we check if the data was persisted. And if it is, we log the user in automatically so that the user doesn't need to re-enter the details. And that's where we can use useEffect. Now let's start with storing the data. Here in the logged in handler, I set isLoggedIn to true. And that's where I want to store that piece of information in the browser storage. Now the browser has multiple storages we can use. The most common storage for this would be cookies or local storage. And since it's particularly easy to work with, we will use local storage. So that's a storage mechanism built into the browser, totally independent of React. Here in the login handler, we could therefore run local storage. This is a global object which is available in the browser. Set item, and then give the item any identifier of our choice, like for example, is logged in, but that's totally up to you. It should just be a string though. And the second argument should also be a string which you store. And for example, that could be 1 to signal that this is that the user is logged in. 0 could stand for not logged in. Of course, you could also have some identifier like this. This is totally up to you. I will work with 1 and 0. So we can set this item here. And if I do this and I save everything, if I do log in again here, I can open up the developer tools thereafter. And there open the application tab or the application part. There you'll find the storage section with the local storage. And if you expand this, you'll find your host, and there you should now find this key value pair. That's stemming from this line. So that's how we can store data. Now we can do this here in the function because it is a function that executes only when the user clicks the button, which is rare enough and which is exactly when we want to store something. So that's now a use case where we don't need useEffect necessarily. But how about the scenario that the app restarts because the user left the page and comes back, or simply because we reload the page? Then we want to check if in local storage we have that key value pair. Now, when the app restarts, this app component function runs again. Now, therefore, here, of course, in this function, we could reach out to local storage, call getItem and search for isLogkedIn, and this will return the item stored there. So that's the stored user logged in information. That's a super long name, obviously. I just want to make it clear what's in there. You would typically use a shorter name, of course. And we could check if the stored user logged in information is equal to 1. And if it is equal to 1, we could call set isLogkedIn and set this to true. So that we set the user to logged in even without this function being triggered. And it would trigger upon pressing the login button normally, just because we know that the user is logged in. And of course, we should do that after calling useState. So we could do that. But the huge disadvantage with that approach is that we would create an infinite loop, because we check for this being stored. If it is stored, we set this to true. And whenever we call a state setting function, this component function re-executes. And therefore, this would run again, would find 1, would set it again, and so on. That's what I explained earlier. So we need useEffect here, because that allows us to control when this runs. Hence, from React, besides useState, we import useEffect like this. And then here, we can simply call useEffect, just like this. And now we pass those 2 arguments you saw on the slide to it. The first argument is a function, for example here, an anonymous arrow function. Doesn't have to be an anonymous arrow function, but often you use just such a function. The second argument is an array of dependencies. Now I'll come back to those dependencies later. For the moment, let's just write it like this. In this function, we can now run this code here, which we don't want to run directly in the component function. Because now this function here is executed by React, and it is executed after, important, after every component re-evaluation. So whenever this component function ran, thereafter, this will run. And if you then update the state in here, the component will run again. But it will not just run after every component evaluation, but only if the dependencies here changed. Now, when the app starts for the first time, that will be the case. If this component function runs for the very first time because your app just started, then the dependencies are considered to have changed because you had, well, no dependencies before, you could say. But once it ran for the first time, for example, with this setup here, we have no dependencies, but therefore, of course, they also didn't change compared to the first execution cycle. So therefore, this anonymous function here would indeed only run once when the app starts, because thereafter, well, the dependencies never change because this here specifically has no dependencies. And in this scenario, that's exactly what we want. We want to run this code once, and that's when our app starts up. So therefore, here we should have exactly the behavior we want. Once the app started, this code runs. Here, we update the state, and as you learned, this triggers this component function to run again. Now, therefore, this all runs again, this JSX code is evaluated, and the DOM is updated accordingly, but thereafter, the effect would run again, but only if our dependencies also changed. And that's not the case here, as I explained. So therefore, this should only run once, and hence, if we save that, and I reload here, you see I'm logged in. I don't end up on the authentication screen, but in the logged in state. And the reason for it is that we have this stored. Now, if I clear that manually by selecting it and deleting it, if I now reload, you see I'm back here because this code still ran, but of course it didn't find the logged in information. If I do log in again so that this is stored, you will see we're back to the behavior from before. If I reload, I end up on this page. So that's use effect, and that's one scenario where it shines a lot. This data fetching is a side effect. It's not directly related to the UI. Of course, the result is, but not the data storage access itself. And we want to run it as a side effect with use effect in this case to avoid an infinite loop and to make sure that this code, which potentially could also be performance intensive, does not run for every component re-render cycle, but only if we want it to run. Now, let's refine our data storage example here by also making sure that when we click the logout button, we again reach out to local storage and we remove the is logged in key there, simply to clear it from there so that we don't have to clear it manually by selecting it here.